Objective 6. Solve quadratic functions with the quadratic formula. Alright, so this objective is the culmination of Module 3. The quadratic formula allows you to solve any quadratic equation that you encounter, whether it be on the test or the EOC. If you don't remember a certain type of factoring strategy like MACAB or finding the GCF, then you can use the quadratic formula. It doesn't matter how many terms exist. If there isn't a B term or if there isn't a C term, you can still use the quadratic formula. It works every time, all right? That's what's so special about it. Now I'm teaching this last because it is very beneficial to know how to factor, because factoring is a lot quicker and a lot easier. The quadratic formula is a little bit more extensive and there's a little bit more room for error, so just keep that in mind as you're rolling through this, all right? But it works every time if you get the hang of how to go about the process. So the quadratic formula you should have seen before. You were introduced to it in Algebra 1, but in Algebra 2 it's the same thing. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right. Let me make note of a couple things. It says negative b, but I want you to consider that to be opposite b. Opposite. So whatever your b term is, it's opposite that in that piece of the formula. So opposite b. And then over here, underneath the radical should look familiar to you. That is the discriminant. So please make note of those two things. All right, so the quadratic formula. We're going to use this to solve given quadratic equations. So within this video, I'm going to do 3 examples. I'm going to do example 1 in its entirety, so I'm going to follow the 6 steps that I've listed, step by step, exactly how I want you to do this process, to show you the entirety of what it would look like. And then in examples 2 and 3, I'm going to show you what happens when the discriminant is negative and the discriminant is a non-perfect square. So the first example, when I'm going to do entirety, the discriminant is a perfect square. Alright, so when you're working with the quadratic formula, there's going to be 3 different things that you encounter based on the discriminant. Whether it's a perfect square, whether it's negative, or whether it's a non-perfect square. Alright, so if I'm given number 1, 2p squared plus 3p equals 20, first step is always the same. I have to put it in the standard form. So I have to move this 20. It's positive, so I'm going to subtract it. I'm going to subtract it to both sides. Cancels out over here, so now it equals 0. And I get 2p squared plus 3p minus 20 equals 0. All right, I am done with step 1. I put it in the standard form. Step 2. Please get in the habit of doing this. Identifying the values for a, b, and c will make step 3 a lot easier. So this was step 1, this is step 2, all right? A equals 2, B equals 3, and C equals negative 20. So far, so good. Now, because I wrote them out, I would love to see you do the same thing, identify and write out A, B, and C. I'm done with step 2. Step 3 becomes very easy. Step 3 says put values into the formula. So I'm going to reference my formula up here. It says opposite b plus or minus. So I'm going to put, and this is step 3 right here, opposite b. So my b is a positive 3. It needs to be negative 3 in my formula, because again, it's opposite whatever my b term is. So opposite b plus or minus the square root, plus or minus the square root. I'm going to make the square root nice and big, because a lot of things are going up underneath that. B squared, so again, whenever you're squaring a variable, please put whatever you're inputting into that variable in parentheses. So b, returning to my original b, so b squared, so 3 squared in this case, minus 4 times, my a goes right here, so my a is 2, and my c goes after that, negative 20. So b squared minus 4ac, so minus 4 times 2 times negative 20, all over 2 times my a, and my a is 2. Alright, I have successfully done step 3. I put all the values into the formula, starting with opposite b, in this case negative 3. Now, step 4 says to simplify the discriminant and rewrite the formula with the new radical, with the new discriminant underneath the radical. Alright, so step 4 and step 5 will change based on what the discriminant is. I'm sorry, step 5 will change based on what the discriminant is. Step 4 will be the same. This process of simplifying the discriminant, okay? if you remember, the discriminant exists underneath the radical. So I'm going to put what's underneath the radical into my calculator, and it's going to give me some new number. If I do that math in my calculator, 3 squared minus 4 times 2 times negative 20, again, you have to just put what's underneath the radical. Don't put the radical in your calculator. What's underneath the radical into your calculator. That gives me 169, all right? Which technically is my D. So I'm going to draw an arrow. D is, that looks like a 1. Erase that and make it look different. My discriminant is 169. If you notice, the discriminant in this case is a perfect square. So if you can imagine, that 169 is going to replace all of those numbers underneath the radical, and that's what step 4 is going to finish doing. Step 4 states I simplified it, so this is part of step 4 over here. Now I'm going to rewrite the entire quadratic formula with the new radical. So I have opposite b plus or minus the square root of 169 all over 2 times 2. All right. Now, at times, and I can put a radical sign over this as well, because technically it's still, the discriminant exists underneath the radical. So this, let's make note that the discriminant is what's underneath the radical, 169. Now, step 4 is done. I rewrote everything. I found the discriminant and rewrote it. Now, step 5 says to simplify the radical if necessary. In this case, it's always going to be necessary. It's just going to look different. Now, I've determined that 169 is a perfect square. I know that to be true, and you can always check this by using your calculator. You take the square root of whatever that number is. So in this case, the square root of 169 is 13. So now I have negative 3 plus, and I want you to write it like this always, all right? So negative 3 plus 13 over, let's do this math now. 2 times 2 is 4. And then negative 3 minus 13 over 4. I want you to separate it. All I did there in that place was I separated the plus and minus. Because you can technically write it like this as well. Negative 3 plus or minus 13 over 4. But if you notice, there are 2 pathways to take now. Because these are all whole numbers, boom, boom, and boom, you can actually do this math, all right? So this is step 5 for this one, and this is how every quadratic formula problem will work if the discriminant is a perfect square. I wanted to separate the plus and minus into a plus and minus because I'm actually going to do this math, okay? Negative 3 plus 13, and I'm going to show this over here. So negative 3 plus 13 over 4 equals, negative 3 plus 13 is a positive 10 over 4 equals, and if I simplify this, 10 over 4 reduces to 5 halves. So one solution is 5 halves. That's this math, all right? Now let's go to the other piece of step 5. Negative 3 minus 13 over 4. That equals, negative 3 minus 13 is a negative 16 over 4, and that simplifies to negative 4. My other solution is negative 4. So I have found my 2 solutions, 5 halves and negative 4. And if you remember from Objective 5 when we were working with the discriminant, if the discriminant is a positive perfect square, like it was, 169, then it will lead to 2 real rational solutions. And in this case, it did specifically that, all right? Now let's look at what happens when the discriminant is negative and when the discriminant is a non-perfect square. Please, at this moment in the video, pause it and get caught up with these notes, all right? So pause it and write down what I have in green for number 2 and write down what I have in purple for number 3. Because after you pause it, I'm going to go through step 5 for each of these because the discriminant is different. So pause it, take a moment to write everything down that I have exactly like I have at steps 1 through 4. and then unpause it and we'll continue. So at this point, you should have paused the video. Let's go over number 2. So step 1, I put it in standard form. Step 2, I identified the A, B, and C's. Step 3, I inputted everything into the quadratic formula. This is step 4, all right? Step 4, I simplified the discriminant, or found the discriminant. I found the discriminant to be negative 144. In step 4, to finalize it, I rewrote the quadratic formula with my new radical, with the discriminant that exists of negative 144. Now, if you notice, the discriminant is a negative number. It's a negative 144. In this case, 144 is a perfect square, and we're going to keep that in mind as well. But a negative number, when you take the square root of a negative, you know that you're going to have an imaginary solution. So you know by the end of this process, you should have an I written in your answers. And if you remember from Objective 5, working with the discriminant, it's going to lead to 2 complex roots, or 2 complex conjugates, okay? Complex root just means that it's imaginary. So let's continue this process. Step 5 says to simplify the radical if necessary. So I'm going to write step 5 here in red this time, and I'm going to separate my plus or minus right here. I do believe Miss Abbott is laughing in the hallway. All right, step 5, I have simplified the radical. All right, the square root of 144. I'll always check. Even if it's a negative 140, even if it's a negative underneath the radical, I'm going to work with the positive number to check to see if it's a perfect square. So I'll take the square root of a positive 144, and that does give me a whole number of 12. That's how I got 12 right there. Now, because of this negative, though, it's a negative 144, I know that I can't technically take the square root of a negative, so that's why I had to put an I. So the I signifies that we're entering into the realm of imaginary numbers. So my final piece of this is negative 4 plus or minus 12i all over 10, all right? Now, step 6, there is a step 6, and at this point, we have to check too, can we simplify the expression at all? So this is the expression, negative 4 plus or minus 12i over 10. Plus or minus means there's 2 solutions. If I look at my whole numbers, all right, so step 6, we're going to simplify. If I look at the whole numbers, I have a whole number of negative 4, I have a whole number of 12, and I have a whole number of 10. They are all even, so they can all be reduced by a factor of 2, okay? So you need to be able to do this as well. So I have negative 4 divided by 2 becomes a negative 2, and I have plus or minus 12 divided by 2 becomes a 6, and this has an I with it. Even though it has an I, you can still reduce the whole number. And it's all over 10 divided by 2 is 5. At this point, I am done, but I am going to show you this can be written like this, or it can be written negative 2 plus 6i over 5, and negative 2 minus 6i over 5. Either format works, and this is my final answer. If you notice, I have x equals this one, and x equals this one. X equals negative 2 plus 6i over 5, and x equals negative 2 minus 6i over 5. They are ugly numbers, they're imaginary numbers, and you cannot combine them because there are pieces that are real and pieces that are imaginary. They're called complex roots. And I'm going to write that, so please make note of that too. Complex roots. Alright, let's move on to the next one. In this case, 1/16 is not a perfect square. It comes out as a decimal. So I actually have to break down this radical. So I'm going to speed this up because I'm running out of time, and I'm going to show you the work to break this down. The discriminant 1/16 isn't a perfect square. I actually have to write it in simple radical form. So this is where I did the factor tree here. I found a pair of 2's, and they come out as this 2 right here. And then 29 is left within the radical. So step 5, I have negative 10 plus or minus 2 radical 29. If you notice, it went from square root of 1/16 to this right here, and that's what I'm looking for if the discriminant isn't a perfect square. And at this point, to simplify it, I have to divide negative 10, 2, and 8 by 2. So I have negative 5 plus or minus 1 radical 29 all over 4. And those are the three ways that you will see in this.